Hello there. In this lesson, we're going to learn about a D flip-flop. Here, as you can see, we have a D flip-flop that has a clock source coming in. I have it set to 5 Hertz for my computer. Uh, you can see here the clock turning on and off on this grapher on the right. What I want to do is explain the behavior. If you've already looked at the video for JK function flip-flop, you're going to see this is almost identical. So if you haven't done that already, I suggest you look at that one first. This one is actually much simpler after you looked at the JK video. So what you should know on a JK, on a D flip-flop, sorry, is that the output, it just follows the input D when the clock is triggered. So what we have here, my input D, I have it set to 1 at the moment. And every time the clock is triggered, you can see here, again, a trigger is a transition from 0 to 1 in this case, because it's a positive edge triggered clock or a rising edge triggered clock. Not when the clock is a 1, not when the clock is a 0, but whenever the clock changes from a 0 to a 1. So I guess in this multi-sim simulation, you can see when it becomes lighter blue, the moment it becomes lighter blue. Here on the graph, I have a probe and it's a green, this green signal is the clock triggering on and off. If D is 0, whenever the clock is triggered, the output becomes 0. Let me zoom in here a little bit so that you see what happens. So I'm going to make D a 0. Notice that the output, I'm going to pause this for a second. Notice that the output, when I made D a 0, so D was a 1. The moment I made it into a 0, the output didn't change. The output is down here in the pink probe at the very bottom. The output stayed on until the clock, this one was letting go of the clock or the falling edge until the clock had another rising edge. So whenever the clock was triggered at this point right here, it said, okay, D is a 0 at this point, so the output becomes 0. Okay, so notice here the clock on the falling edge, nothing happens at the output Q. The output Q is only going to change whenever the clock is triggered. If I press play again, I'm going to make D a 1. And then I'm going to pause it again so you see. So here, D became a 1, and it was a 1, but the clock here, the output only changes not on the falling edge, but on the rising edge. So at this point right here, when it transitioned from 0 to 1, D was a 1 and the output became a 1. So I'm going to keep toggling D from 0 to 1 and notice that the output only happens on the positive edge or the rising edge of the clock, not on this falling edge, but on the rising edge. There you go. So I'm going to make it a 0 now. And the falling edge was right next to it. Toggle a few times. So the blue is me flipping the switch on and off. Let me pause the simulation. So here, even though, notice, even though D was turning on and off as I was clicking the input switch, the output was only changing when the clock was on the rising edge, on the positive edge trigger. So right here, the output changed. Falling edge, nothing happened. Rising edge, yep, right there, as you can see, this is when it changed. Falling edge, nothing happened. Rising edge, it changed. And I happened to catch it, so it's a nice and square wave, but it doesn't have to be like that. It's just whatever the input Ds. You notice here, I'm going to turn it on. I'm going to turn it on and off like as quickly so that you can see how. There you go. And now I'm going to pause it. So notice here, I went on and on and off, and the output was only changing here. So at this moment, when the clock was a falling edge, nothing happened. At the rising edge, it happened to catch it when D was 0. So the output is 0. Here at the falling edge, nothing happens. Rising edge, it caught it when D was 1. So the output became a 1. Falling edge, nothing. Rising edge, D is a 1. So it stayed a 1. So a lot of times people call these flip-flop the transparent flip-flop because the output follows directly what the input is. So that's how a D flip-flop works. Oh, by the way, the overrides work the same in any flip-flop. As soon as you activate them, in this case, a 1 activates them. If I override the output with a 1, the output Q is going to be a 1. Even if I force a 0 here, the output's going to stay a 1 until I let go of my signal. Then at C notice here, I let go. And then at the next trigger, my output Q changed. If I override a 0, the output stays 0 no matter what. It was always already 0. If I let go, it stays as a 0 unless something else changes. If I put D to be a 1 now, the output is going to be 1. I want to show you one last thing before I finish this, and that is there is, as you can remember on a JK flip-flop, we had 4 different states. We had the output 0, 0 remembered the previous state of Q, so that was the remembering state. The 0, 1 was a reset, 1, 0 was a set, and 1, 1 was a toggle. So that one had lots of different states. The D flip-flop just really has 2, 0, it outputs a 0, and 1 outputs a 1. There is a way to make a D flip-flop toggle, and that is by always having the opposite of the output ready at the input. So how you do that is you connect the output inverted Q, connect it around this way. Oh, I guess it doesn't matter which way it goes. And then connect it into the input D. So what's gonna happen is when I start the simulation, or when you start it, my output, let's say it's a 0, Q is a 0. The inverse of Q is going to be a 1. So there's going to be a 1 ready at D. So when the clock triggers, the output is going to change to the opposite. So basically at D, the opposite of the output, which is not Q, is always waiting. So as you can see here, I'm not flipping any switches. The clock is being, every time the clock is triggered from a 0 to a 1, so here in the green section, every time it goes from a 0 to a 1, the output toggles to the opposite state, as you can see. And you can see here in blue, the blue is always the opposite of the pink because the output Q is in pink, and so the opposite of Q is waiting at the next state. So I just wanted to show you that. So to summarize, the D flip-flop is simpler than the JK flip-flop. The D flip-flop, whatever's waiting at D becomes Q when the clock is triggered, unless the overrides are active. If you want to make a D flip-flop toggle, you connect it just like this. You connect the opposite of Q, so inverse Q, into the input D. All right, that's it for now.